I'm Deanna Rivera. After you learn the differences between scalar and vector, which will be related to our next topic, the linear motion.
For this discussion, you will learn what linear motion is, differentiate what is distance from displacement, speed from velocity, what is acceleration, and an example of linear motion.
First, let's determine what motion is. Motion is the relationship between the distance traveled and the time taken. Before we proceed in linear motion, let's define first and differentiate the distance from displacement and speed from velocity. What is acceleration?
Starting with the distance and displacement. For example, a girl is about to walk to reach her destination. If this girl will move like this, what is the distance and displacement? This will be the distance or the actual length of the path traveled by a moving body in a given interval of the time traveled. But what is displacement? It is the shortest distance measured between initial and final position. If there are infinite numbers of paths from the initial to final position in distance, there is only one possible path in the case of displacement.
Let's now move to speed and velocity. Speed is defined as the distance of a moving object per time taken. It is represented by a scalar and measured by meter per second, while velocity is defined as the displacement of a moving object per time taken from its initial to final position. It is a vector and measured by meter per second. Then what is acceleration? Acceleration is the rate of change in velocity. When the velocity speeds up or slows down, its acceleration will also change. I have a ball. How can we say that this ball I am holding right now will be in linear motion if I throw it? Simple. If this ball will move like this, vertical pathway or horizontal pathway, it exhibits linear motion. In other words, linear motion is a one-dimensional motion. It is along a straight line. It is either vertical or horizontal. As I mentioned earlier, there is an example of linear motion. It is the free-falling bodies. Do heavy bodies fall at a faster rate than the lighter bodies, or do they fall at the same rate? Consider the case of the feather and a coin. In air, the coin falls faster than a feather, due to air resistance having a great effect on light bodies than heavier bodies. But what is free-falling body? It is a body moving under the influence of gravity alone. All objects in free fall near Earth accelerate at the same rate. This rate is called the acceleration due to gravity, or denoted with the symbol of g, and with the approximate value of 9.8 meter per second squared, or 981 centimeter per second squared, or 52 feet per second squared. When the acceleration is directly downward, this acceleration is in negative.
Let's take this as an example for free-falling motion. An amount of syrup is being poured in a cup 0.30 seconds later. What is its velocity in meter per second? How high the container of syrup from the cup?
The given value are 0.30 seconds per time and negative 9.8 meter per second squared for the approximate value for acceleration due to gravity. We are to get the velocity using the equation, the acceleration due to gravity times time. Then, substitute for the given values. Negative 9.8 meter per second squared times 0.30 seconds. Then cancel out for the second. The answer would be negative 2.94 meter per second. The velocity of the
syrup being poured in the cup is negative 2.94 meter per second.
We are now to compute for the height, using the given value earlier, 0.30 seconds for time, and 9.8 meter per second squared for acceleration due to gravity. Since there is no negative in height, we will take the positive value. We will use the equation height is equals to gt squared over 2. Then substitute for the given value. 9.8 meter per second squared times 0.30 second squared over 2. Cancel for the unit of time. And the answer will be 0.44 meter. The height of the syrup from the cup is 0.44 meter.
After discussing the linear motion, I'm Karla Camarao to discuss nonlinear motion. Nonlinear motion includes projectile motion, rotational motion, and circular motion. For this discussion, we are to define projectile motion and enumerate its components. Define, describe, and differentiate rotational and circular motion. Show application for nonlinear motion. Projectile motion is the motion of body shown horizontally with an angle other than 90 degrees with horizontal. Projectile motion has two components. First, the vertical, and the second is horizontal. Rather than dropping an object straight down, what happens if you throw it horizontally? Here is an example of projectile motion. There are four components of projectile motion: the range, trajectory, peak, and the projectile. Let us discuss it one by one. Range is the horizontal distance the projectile travels. Trajectory, the path that a projectile follows. Peak, it is the highest point of the projectile. Projectile, the object that are thrown or launched into the air. Now, let's proceed to rotational motion and circular motion. How to differentiate rotational motion from circular motion? In rotational motion, the object spins around its axis, while in circular motion, the object as a whole travels along the circular path. For example, in rotational motion, the Earth moves around its axis, while in circular motion, the Earth revolves around the Sun.
Dr. Schleiniger Pharmatron's model FTV2 is specially designed to determine the durability of tablets from the time of production to the time of use. As it is important to test abrasion and impact hardness of tablets, the tester consists of two transparent acrylic drums which rotate at 25 RPM plus or minus 1 RPM as specified in the USP. The microprocessor-based FTV2 allows precise control of both velocity, 20 to 90 RPM, and time, 5 to 900 revolutions. The membrane switch front panel is easy to read, and the LCD display provides the user with intuitive menu of functions.
For this topic, we have two values to be considered. First, learn to be honest in reporting data and results, and learn to respect each other and seek to understand why we have different opinions. I'm Deanna Rivera.
And I'm Karla Camarao
of BS Pharmacy
from Our Lady of Fatima University. Thank you.